Hola everybody! So today what we're going to do is we're going to learn about 9.3, solve the quadratics by completing the square. And how we're going to do that is going to be extremely fun, and you're going to love it, and you're going to be laughing and smiling the whole way. It's going to be awesome. So another method for solving quadratic equations, like I just said, is completing the square. And if I could write better on this, it would be fantastic. However, I can't. Or maybe I can, I just don't care enough to go slowly. This method, you must add a constant to create what is called a perfect square trinomial. Now, hopefully you've heard that before, because I have said it. And a perfect square trinomial is basically the easiest trinomial to factor. And the reason we're going to do that is because it makes it so easy. Basically, if I get to the position where I don't have a greatest common factor, I can't, just do some square roots, I can't graph it out easily enough, completing the square is going to make it a lot simpler. Okay? So an example of a perfect square trinomial would be something like x squared plus 6x plus 9. And the reason it's a perfect square is because if I look for factors of 9 that add up to 6, those numbers are going to be 3 and 3. Right? So my factors are going to look like x plus 3 and x plus 3. Now we've seen this happen before, where the two factors are the exact same thing. That's a perfect square trinomial. Okay? So let's see. How do we complete the square, and how do we make these perfect square trinomials? Well, what we do is we take the b term, okay, and we're going to take half of it. So find half of the b term, and what we're going to do is we're going to take that term, cut it in half, and then step 2 is we're going to square the result. After we've taken b, cut it in half, squared it, then we're going to add the result to the entire polynomial. Okay? So let's see what that looks like in context. Taking the b term, cutting it in half, squaring it, and then adding it. So here I have x squared plus 6x. My a term is a 1, my b term is a 6. To make this a perfect square trinomial, what I'm going to do is I'm going to take the b term, cut it in half, so that's 3, square it, that makes 9, and add 9 to both sides. Okay, so let's just do that out again. The b term is 6, so I'm going to cut it in half. 6 over 2 equals 3. Okay, and then I'm going to square it. 3 squared equals 9. Alright, so that's the number that I add onto here to make this a perfect square trinomial. Easy enough? Let's try it again. My a term is a 1, my b term is a negative 9. What I'm going to do is I am going to cut it in half. So negative 9 over 2, no reason to make it any more complicated than that. And then I'm going to square it. Negative 9 over 2 squared. That makes a positive 81 over 4. And that is the number that I would add to both sides here. Plus 81 over 4. Easy enough? Cool. So now let's go about solving this equation by completing the square. This is where, we have to remember one extra step. Okay, so what I want to do here is try and get everything on one side first, and then we can worry about completing the square. And actually, this might be a little confusing. This says equals 3 equals 17. Let's go ahead and subtraction sign there. That's supposed to be subtraction. So what I'm going to do is I'm going to go ahead and move this 3 to the other side. Now, why am I going to do that? So it says x squared plus 8x equals 20. Why did I move this 3 to the other side? Well, on the left side here, what I have is an imperfect trinomial, if that's what you want to call it. It's not in the format where the factors of this add up to this, and it's nice and easy. It's a perfect square. It's not like that. If I look for factors of 3 that add up to 8, it's not going to be factorable. So if I move the 3 to the the other side. I leave this so I just have a equals 1. 1 second. My apologies, I was just interrupted by a phone call, apparently. That's new. Hasn't happened. But let's continue. So I've moved the 3 over here. That way I have my a equals 1 and my b is 8. And it allows me to have kind of this open space where it says x squared plus 8x plus what? To make a perfect square trinomial equals 20. And it gives me this free open space for me to add that number in there instead of having a 3 in the way. Okay, so now let's complete the square. I'm going to take the b term, cut it in half. So 8 divided by 2 is 4. 4 squared is 16. So the number I'm going to put in here is 16 to make this a perfect square trinomial. However, we haven't faced this before, but I have 2 sides of the equation, which means if I do something to one side, I also have to do it to the other side. So I can't just add 16 there, I also have to add 16 over here. Alright? So what I end up with is this trinomial equals 36. Now, I, completed the square over here to make this easily factorable so that it can get down to the point of x plus 4 squared, right? Because factors of 16 added to 8 will be 4 and 4, so x plus 4 squared is my factored form, which means all I have to do is take the square root of both sides, gives me x plus 4 equals plus or minus 6, and then we're going back to solving equations by square roots, right? Now I'm going to add 4, so x equals 4 plus or minus 6. And those are my 2 answers, 4 plus 6, which is 10, or 4 minus 6, which is going to be 2. Oops, sorry, this should be negative 4, because I'm subtracting 4 from both sides, negative 4. So negative 10 or positive 2. Alright, that's actually it for this one. Hopefully this wasn't too bad. As always, we'll go over in class and clear up any issues that we have.